Okay, I just want to make sure that we're happy with a quick method for finding the distance from a plane to the origin. So in this diagram, I'm looking side on at the plane here. So let's call this the plane r dot n is equal to p. And I'm interested in the shortest distance, of course. So this distance here is what I'm looking for. There's the origin. Now, I also know that I've got a normal vector, normal to the plane there. I also know that this will enable me to find the position vector of any old point on the plane. That's what r is. It's the position vector of a point on the plane, which means it links the origin to any point on the plane. So from this diagram, I can see that the distance that I want is the projection of this vector onto the normal. So I can write quite easily d is equal to the projection of r onto n, which I also know is project r onto n, it's r dot n divided by the magnitude of the vector you're projecting onto, divided by n. And this simplifies nicely because I know that for any point on this plane, r dot n is equal to p. So this becomes p over the magnitude of n. So the formula that we have for the distance of a plane to the origin is p over the magnitude of n. So very quickly, for the example that we may have just looked at, if I've got the plane x plus 2y minus z is equal to 5, let's just call this a quick example. Then a quick sketch, here's my plane, here's the origin, let's say I'm after this distance here. I know that the normal vector in this case is 1, 2, minus 1, 1, 2, minus 1. That's a vector drawn there. Then I know that using my formula, distance is going to be equal to p, which is 5 over the magnitude of the normal vector. So 1 plus 4 plus 1 is 5 on root 6. If I rationalise the denominator, I get that to be 5 root 6 on 6. So using that formula, I can get these distances really easily.